Welcome back. In this outcome, we're going to explore the wonderful variety of input and output devices out there, how they work, and how to pick the right one for the job in hand. Let's start with the basic idea. An input device sends data or instructions into the computer, like a keyboard carrying your keystrokes, while an output device takes the processed results and presents them back to you, like a monitor showing the picture. Together, we call them peripherals because they sit around the central processor. Over the next few slides, we'll look at 8 input devices and 3 output ones, and where each really shines. Here's the cast of characters we'll be meeting. On the input side, there's the keyboard, mouse, scanner, microphone, webcam, touchscreen, graphics tablet, barcode reader, and sensors. And on the output side, the monitor, printer, and speakers. Some devices happily do both jobs. A touchscreen takes your touch as input, while also being part of the display. Which one you reach for really comes down to the task, the person using it, and where they're working. Let's see how the first 3 actually work. When you press a key, it completes a tiny circuit, and the keyboard sends a code for that key, which the computer turns into a character on screen. An optical mouse shines an LED down onto the desk, and a little camera photographs the surface thousands of times a second, working out how you've moved. And a scanner runs a bright light and a row of sensors across a page, measuring the reflected light to build up a digital image. On to the next 3. A microphone has a thin diaphragm that wobbles with the sound waves, and that movement becomes an electrical signal, which the sound card then digitizes. A webcam focuses light onto an image sensor that grabs frames many times a second, giving you smooth live video for a call. And a capacitive touchscreen notices the tiny change in electrical charge where your finger lands, then reports those coordinates back to the operating system. And the last group of inputs. A graphics tablet tracks a stylus across a pressure-sensitive pad, sending both position and how hard you press, which is perfect for detailed drawing. A barcode reader scans the light and dark bars on a label and decodes that pattern into a product number. And sensors measure something physical, temperature, light or motion, and turn it into data, which is exactly what's happening inside your phone, your car, and a smart home. Let's slow down on 2 of these because they explain some everyday quirks. An optical mouse lights the surface and rapidly compares snapshots to judge direction and speed, which is precisely why it struggles on shiny glass. There's no texture to lock onto. A capacitive touchscreen relies on your finger drawing off a little of its electrical charge, and that's why ordinary gloves often don't work. They simply don't conduct. Little details, but they suddenly make sense once you know the mechanism. Now for the 3 output devices. A monitor is a huge grid of pixels, each made of red, green, and blue subpixels lit from behind, and together they build the image you see. A printer either sprays microscopic ink droplets onto paper, in the case of an inkjet, or uses a laser, static charge, and heated toner to fuse the image in a laser printer. And a speaker takes an electrical signal and pushes a cone back and forth, shoving the air to create the sound waves your ears pick up. A couple more useful details on output. With monitors, the resolution is just the number of pixels, so something like 1920 by 1080. And more pixels means a sharper picture, while the refresh rate in hertz tells you how often it redraws. Inkjet printers are cheap to buy and lovely for photos, but the ink can cost a fortune per page. Laser printers, by contrast, are fast and cheap per page for text, which is why offices love them. This table brings all 11 devices together at a glance, with a one-line reminder of how each works. You can run your eye down the input column, from the keyboard sending character codes to sensors measuring the physical world, and then the output column, from the monitor's grid of pixels to the speaker's vibrating cone. It's a handy summary to come back to, and if you can explain any row in your own words, you're in good shape. Now we shift from how devices work to which one you'd actually choose. Assessing a device means judging how well it fits a particular task, person, and setting, weighing things like accuracy, speed, cost, portability, and durability. The best choice for a busy warehouse is quite different from the best choice for a graphic designer. The key is that you justify your pick with reasons rather than just naming devices. This slide matches each device to the jobs it does best. A keyboard suits fast text entry like essays and coding, a graphics tablet suits digital art, and a barcode reader is made for retail checkouts and stock control. Sensors turn up everywhere, from smart homes to fitness bands, while monitors, printers, and speakers cover your viewing, hard copy, and audio. Seeing them lined up against real uses makes the right choice much more obvious. Let's watch a few of these working together at a supermarket till. The barcode reader instantly identifies each product and its price, far quicker and more reliable than typing it in. The operator uses a touchscreen to pick loose items like fruit, a weighing sensor prices the produce by weight, and a receipt printer prints the itemized list while a small monitor shows the running total. Every device is there because it makes serving the customer faster, more accurate, or clearer. Now, a completely different setting, a freelance illustrator's workstation. Here, a graphics tablet and stylus allow natural, pressure-sensitive drawing that a mouse could never match, and a scanner digitizes hand-drawn sketches so they can be tidied up on screen. A high-resolution monitor shows fine detail and accurate color for professional results, and a large color printer proofs the final artwork before it goes to the client. Notice there's no barcode reader in sight. The tools reflect the task. It's really important to assess devices for accessibility because the same device can help one person and hinder another. Touchscreens suit people who find a mouse awkward, microphones open up voice control and dictation, and large monitors with screen zoom help those with low vision. But small touch targets can be tricky for anyone with limited dexterity, and a microphone becomes unreliable in a noisy room. Good assessment always asks who is going to be using this and where. Let's weigh up two printers as a proper judgment call. An inkjet has a lower purchase price and produces gorgeous photos, but it's slower and costs more per page once you factor in the ink. A laser printer is quicker and far cheaper per page for text, which is ideal for an office churning out documents. So a home user printing the odd holiday snap might choose inkjet, while a busy office picks laser. The best printer genuinely depends on what you're printing and how much. Sensors deserve a slide of their own because they're quietly everywhere. They turn the physical world into data, measuring temperature, light, motion, or your GPS location. And they power smart homes, fitness trackers, cars, and industrial monitoring. Biometric inputs like fingerprint and face scanners are really just sensors used for secure login. As devices shrink, sensors let computers notice and respond to their surroundings all on their own. Here's a case that really shows why you assess per person. A college is setting up a workstation for a student with limited vision and reduced hand movement. A microphone with speech recognition lets them dictate their work instead of typing. A large high-resolution monitor with screen zoom makes text easy to read, and speakers with a screen reader read the content aloud. A standard keyboard and mouse just wouldn't suit here, and choosing the right mix of devices removes the barriers and includes the learner. So let's draw the threads together. No single device is best for every situation. It always depends on the task and the setting. In retail, speed and accuracy push you towards barcode readers and touchscreens, while in design, precision favors graphics tablets and high-resolution monitors. A good assessment weighs several factors and then justifies the final choice with clear reasons. And that reasoning is exactly what the marker is looking for. Let's recap what we've covered. Input devices send data into the computer, and output devices present the results back to us. We looked at 8 inputs: the keyboard, mouse, scanner, microphone, webcam, touchscreen, graphics tablet, barcode reader and sensors, plus 3 outputs: the monitor, printer and speakers. Each one converts between physical actions and digital signals in its own way, and assessing a device means matching it thoughtfully to the task, the user and the setting. And that wraps up our tour of input and output devices, where we've seen how each one works and, just as importantly, how to judge which fits a given job. If you'd like to dig deeper, the reading here is a great next step, with How To Geek and BBC Bite Size offering clear explanations of the hardware. The W3C accessibility guidelines are well worth exploring if the accessibility side caught your interest, and the BCS glossary is handy for firming up the vocabulary. Have a look through the sources listed and follow whatever draws you in. And next time we'll turn to backing store and how computers keep your data for the long haul.